Our last conic is the hyperbola, which is section 7.4. Again, we have two equations because we're going to keep our hyperbola centered at the origin. We want to recognize its equation when it's not in standard form and be able to put it in standard form. And we want to use the equation to tell which axis is the transverse axis and where the vertices are. The definition of a hyperbola is the collection of all points in the plane, the difference of whose distances from two fixed points is called the foci, and it's constant. So this difference is constant, and for an ellipse, the sum was constant. So let's look at the parts. The orange here, these two parts make up our hyperbola. If you recall, it is in two parts, as we saw when we looked at the different conics. Okay, and then we have a transverse axis, which is the one that actually comes in contact with the graph. We have the conjugate axis, which comes between but does not touch the graph. We have some asymptotes here that show how the parts of the graph approach. And this fundamental rectangle, which connects the vertices to these points here to form this rectangle. So, again, we want to know our the A and the B. So A is this distance here from the center to the vertex. So this vertex would be A0, and this vertex would be negative A0. And then the B in this case goes out to the fundamental rectangle here. So here, even though this is not on the graph, it still defines this rectangle where the asymptotes go through the corners. So this is 0B, and this one here is 0, negative B. Okay, so just to get the general pieces, and then we're going to look at the two types of these and come up with their equations and everything. But I want to point out the different pieces, the fundamental rectangle, and how they relate to the asymptotes and where A and B are. In this case, of course, the transverse axis is the x-axis. But you can imagine the same thing if the transverse axis were the y-axis. So we'll look at that. Okay. So here are our two cases. We are centered at the origin. This is the one we just saw, where x is the transverse axis. That's this one. The equation, x squared over a squared minus y squared over b squared equals 1. So remember, it had the difference in the definition. The vertices are at plus or minus a0, as you can see here. Okay, and you can imagine, so if we had those asymptotes running here and here, and then we have our fundamental rectangle coming down. Let's see, probably didn't put that in the right place, but it would come down something like this, and then we would know where our B coordinates were, right? So that's the idea. Okay, of course here, the axis that comes in contact with our graph is the y-axis. And the equation now is y squared over a squared minus x squared over b squared equals 1. And the vertices are 0 plus or minus a. Okay, so a is not necessarily the larger number. It could be the larger one, it could be the smaller one. But if you have it in standard form, how can you tell which axis is transverse? Well, in standard form, it's the one that's first, right? If you have the subtraction between them, you've got it in this format, then clearly it's the one that's first. Or the positive one, if you want to say that. Okay, example 1, see we're in standard form already. So the transverse axis is the x-axis because it's first, it's positive, right? Okay, so a squared is always under whichever one is first. That's how we decide that. So let's make a note. A will then be the square root of 4 or 2, and b will be the square root of 21. There's no relationship about which one's bigger. That doesn't matter anymore. If we're on the x-axis, the vertices are at 2, 0, and negative 2, 0. Okay, our next example is not in standard form because it is not equal to 1. We saw this before with the ellipse. So if we divide everything by 32, then we get what? Y squared over 16 minus x squared over 4 equals 1. And what is a? Well, a is the square root of 16 or 4. How did I know it was 16, square root of 16? Because that's what's first, right? Because the y-axis is transverse. A is 4, and b is the square root of 4 or 2. So the vertices on the y-axis would be 0, 4, and 0, negative 4. Okay, 3 more examples. Let's get through these. Okay, again, not in standard form. So we have what? X squared over 16 minus y squared over 32 equals 1. So the transverse axis, the first one is x squared. So a squared is 16, so a is the square root of 16, or 4. And then the other b squared must be 32, so b is the square root of 32, which is 16 times 2, or 4 square root of 2. Is that right? Okay, and so now that we're on the x-axis, that means our vertices are 4, 0, and negative 4, 0. Okay, 6y squared minus 2x squared equals 18. Divide all the terms by 18 to get y squared over 3, x squared over 9, and 1. Okay, so this is transverse axis, y-axis. So that must be a squared. So a is the square root of 3, and b is the square root of 9, which is 3. And the vertices on the y-axis are going to be 0, square root of 3, and 0, negative square root of 3. Last one, 7x squared minus 5y squared equals 35. So we get x squared over 5 minus y squared over 7 equals 1. So a, what's our transverse axis? It is the x-axis. And a is the square root of 5. And b is the square root of 7. And the vertices are on the x-axis, so they are the square root of 5, 0, and negative square root of 5, 0.